Right, in this question, we have to draw the graph of y equals 1 plus x minus 2x squared using our knowledge of calculus. So first of all, we need to know whether this curve, and it will be a curve, it'll either be a maximum curve or a minimum curve, based upon the fact that we're dealing with an x squared term. So the first thing we do is we get the gradient function. So we find dy by dx. Now this is 1 minus 4x. Now remember, at the top or the bottom of the curve, where the tangent meets it, the gradient will be 0. So if we set the gradient to 0, we have an equation that we can solve. And we rearrange this equation to get that, which means that x equals a quarter. So what this means is, if we've got a set of axes where x equals a quarter, which is approximately here, we've got either a maximum curve, it may look like that, or a minimum curve, but the point is, where x equals a quarter, we've got a minimum point or a maximum point. Now the way that we can work out whether it's a minimum curve or a maximum curve is we can look to the left and right of x equals a quarter. So the most obvious place to look now is when x equals 0. And what we're looking for this steepness of the curve. Is it a positive or a negative gradient? So once again, using the gradient function that we've found out already of 1 minus 4x, we will substitute the value of x equals 0 into this gradient function. So let's do that now. So when x equals 0, dy by dx will equal 1 take away nothing, which is 1. Now that's a positive number. Now let's look to the right of x equals a quarter. So the first whole number is 1. So dy by dx is equal to 1 take away 4, which is minus 3. So this means to the left we've got a positive, and to the right we've got a negative. Now the only curve that matches that is a maximum curve, because we're positive gradient to the left and negative gradient to the right. So what we now need to find out is the exact turning point, the actual coordinate of that turning point there. So remember, the original equation was y equals 1 plus x minus 2x squared. And we know that the top of this curve, x is equal to a quarter. We know that already. So let's substitute x equals a quarter into this equation, original equation, to get the corresponding y value. So the y value would be 1 plus a quarter take away 2 lots of a quarter squared. Now that's 1 plus a quarter minus 2/16. So just to make that clear, that bit there would give us 2/16. So we'd obviously turn the quarter into 16ths. So y is equal to 1 plus 4/16 minus 2/16. So that gives us 18/16, which is 9/8 when simplified. So looking back at the original picture, that coordinate now is a quarter, which was the x value, and the y value is 9/8. Now what we can also do now, let's look back at this original picture. We can also find where this curve crosses the y-axis. Now, wherever it crosses the y-axis, the x value must be 0. So, let's substitute when x equals 0 into the original equation. So y is equal to 1 plus 0 minus 0. So y must equal 1, giving me a coordinate of 0, 1. Let's mark that on the diagram. So that there is 0, 1. And the final bit that we could do, we could find out where, doing a different colour, where the curve crosses the y-axis. Now, to find where a quadratic crosses the y-axis, we have to solve y equals 1 plus x minus 2x squared, and we do that by setting it to 0. Now, at this stage, let's use a bit of thought here. Let's rearrange this into 2x squared minus x minus 1 equals 0. Now we're looking primarily for smiley face quadratic factorisation. That does exist on this occasion, giving me 2x plus 1 and x minus 1, which means the solutions are x equals minus a half and x equals 1. So we've finished the question and we might as well draw it. So here's one I prepared earlier. We know that the y-axis crossing points are minus a half and 1. We know it crosses the x-axis crossing points are minus a half and 1. We know the y-axis crossing point is at 0, 1, and we know that the maximum coordinate of the turning point is a quarter, 1 and 1/8. So the curve would look like that. And there you have it.